Let's have a look at this problem. 1 gram of water at 100 degrees centigrade is mixed with 1 gram of ice at 0 degrees centigrade. What is the resultant temperature? That's the question. Here it's very clear that water at 100 degrees centigrade is hot body, it will lose the heat. Ice at 0 degrees centigrade is cold body, it will gain the heat. So, maximum heat that can be lost, that can be released by water at 100 degrees centigrade is, what it will do is it will come down itself from 100 degrees centigrade to 0 degrees centigrade. So how much heat maximum that it can give? Ms delta T. When there is a change in temperature, that's the formula basing on the definition of specific heat. Mass is 1. Specific heat of water is 1 calorie per gram per Kelvin. Delta T is 100, so that is equal to 100 calories. So it can give you a maximum of 100 calories. Who will take it? This ice at 0 degrees centigrade will take it, right? So what we can do in that case with respect to ice? Ice of 1 gram at 0 degrees centigrade by absorbing heat that is available from the water, what it will do first? Convert into water with how much of heat energy? dq1 equal to ml. Mass is 1 gram. Latent heat of ice is 80 calorie per gram, so that is equal to 80 calories. So out of the maximum 100 calories available, 80 calories is used by the ice to convert into water. Now, with remaining heat energy, what is the remaining heat energy? Out of 180 is already gone. 100 minus 80, that is 20 calories. It can't rise to obviously 100 degrees centigrade, because to rise to 100 degrees centigrade, how much heat is required? Ms delta T. M is 1, specific heat is 1 because ice is already converted into water. Delta T is again 100, that is 100 calories. It need 100 calories for this ice to rise to 100 degrees centigrade. But the available heat is only 20 calories. So that implies what you can say is ice can't rise to 100 degrees centigrade. It means to say this also is not going to fall from 100 to 0. So what is going to happen is, as a result, what we can see is that implies both this water and ice together get a new resultant temperature that is greater than 0 degrees centigrade but less than 100 degrees centigrade. How much is that? Let us try to derive it, right? Let us try to derive that. How can we derive that? We can say heat lost by hot bodies gained by cold body. So what is heat lost by hot body? This one, right? So it will fall its temperature Ms delta T, that is mass is 1 gram, specific heat is 1 calorie per gram per Kelvin for water. Delta T is, it will fall from 100 to a new temperature X. That is taken over by ice at 0. First thing is that ice has to convert into water, that is ml. Mass is 1, latent heat is 80 calorie per gram. Now this ice is already converted into water, so mass is 1 gram of this water. Specific heat of water is 1. Delta T is, it is going to rise from this 0, conversion happened at 0. to a new temperature x. That implies 1 into 1 into 1, 100 minus x is 100 minus x equal to 80 plus 1 into 1 into x. So 100 minus 80 equal to 2x. 20 equal to 2x. It implies x equal to 20 by 10. That is 10 degrees centigrade. That implies the resultant temperature is 10 degrees centigrade. So if you notice little carefully, water of 100 degrees centigrade has fallen from 100 degrees centigrade to 10 degrees centigrade. 1. Ice at 0 has done two things. First, converted into water. Then that water temperature, ice converted water temperature, raised from 0 to 10 degrees centigrade. That's a basic understanding that you need to understand. So I want you to understand that why not the entire temperature fall from 100 to 0, rather only fall to 10 degrees centigrade. For that, I have explained to you that for ice to convert into water, it needs 80 calories. For that water to rise to, say, from 0 to 100 degrees centigrade, it need one more 100 calories. Together, it need 180, 180 calories. But available heat is only 100 calories. So something via media happens this way, and they will get a resultant temperature of 10 degrees centigrade. That's how we have to understand that problem. Thank you for watching.